The scale of financial activity within ballast procurement reveals why this seemingly simple material drives complex economic decisions across the global railway industry. Transportation costs often exceed material costs for ballast, making quarry location relative to railway projects a critical economic consideration. The expense of moving thousands of tons of stone across hundreds of kilometers can double or triple the delivered price compared to quarry gate prices. Railways must factor these transportation expenses into their project economics, sometimes choosing inferior local materials over superior distant alternatives, purely for cost reasons.
The transportation challenge becomes even more complex for island locations or landlocked regions where
multiple transportation modes increase handling costs and delivery times. Quality versus cost trade-offs require engineers to balance initial ballast expenses against long-term maintenance costs and service life expectations. Premium granite ballast might cost significantly more per ton, delivered while acceptable limestone alternatives cost substantially less, creating pressure to choose cheaper options. However, the superior durability of granite extends service life considerably, fundamentally changing the economic calculation. Engineering analysis must consider maintenance frequencies, track closure costs, and equipment mobilization expenses that occur repeatedly with inferior materials. The hidden costs of frequent maintenance often exceed the initial savings from cheaper ballast, making quality materials the economically rational choice despite higher upfront expenses. Regional pricing variations can be extreme, with ballast costs differing by 300 to 500% between areas with abundant local stone and regions requiring long-distance transport. Quarry gate prices in stone-rich regions might be relatively modest for premium granite, while the same material to ballast poor regions can cost several times more after transportation and handling charges. These dramatic price differences create economic incentives for long-distance ballast trade, with specialized shipping operations moving millions of tons annually between continents. Regional price disparities also influence railway development strategies, encouraging concentrated construction in areas with favorable ballast economics while discouraging expansion in high-cost regions. Large infrastructure projects like high-speed rail lines can consume millions of tons of ballast, creating temporary market demand spikes that affect pricing globally. Major railway construction projects represent more than the annual production capacity of many regional quarries, creating boom and bust cycles in ballast markets with prices spiking during construction phases and decline when projects complete. Quarry operators must carefully manage capacity expansion to avoid overinvestment during temporary demand surges. These megaprojects strain global supply chains and require careful coordination between multiple suppliers to meet delivery schedules. Long-term supply contracts between railways and quarries help stabilize pricing but require accurate forecasting of maintenance and expansion needs. These contracts typically span multiple years and involve substantial tonnages of material, creating significant financial commitments for both parties. Railways benefit from price certainty that enables accurate budgeting and project planning, while quarries gain revenue stability that justifies equipment investments and capacity expansion. However, contract negotiations must account for inflation, fuel cost fluctuations, and changing regulatory requirements that affect production costs. Force majeure clauses protect both parties from unforeseeable events like natural disasters or economic disruptions that could affect contract performance. Economic analysis includes hidden costs like track downtime during ballast replacement, which can exceed the material cost for busy railway corridors. High-traffic passenger lines generate substantial revenue per hour, making maintenance windows extremely expensive. Freight corridors carrying coal or containers can lose significant revenue for each day of track closure. These opportunity costs often dwarf the actual ballast replacement expenses, creating powerful incentives for maintenance strategies that minimize service disruptions. Railways increasingly invest in premium ballast materials and advanced maintenance equipment that reduce closure frequencies and duration, improving overall economic performance despite higher initial costs. International trade in specialized ballast materials creates opportunities for developing countries with suitable geology to export to major railway markets. Countries with abundant high-quality stone deposits have developed substantial ballast export industries serving global markets. These exports generate foreign currency earnings while supporting local employment in quarrying and transportation sectors. However, Developing countries must balance export opportunities against domestic railway development needs, ensuring adequate supplies remain available for local infrastructure projects. Environmental concerns about quarrying operations also create tensions between economic opportunities and conservation objectives that governments must carefully manage. Technology investments in ballast production and maintenance equipment require substantial capital but can reduce long-term operational costs significantly. Modern ballast cleaning machines represent major capital investments but can process thousands of tons per hour with minimal labor requirements. Automated quarry operations reduce production costs, while improving safety and environmental performance. Advanced materials testing equipment ensures consistent quality that reduces maintenance requirements and extends service life. These technology investments often pay for themselves within reasonable timeframes through improved efficiency and reduced operating costs. Railway financing institutions now recognize ballast economics as a critical factor in project viability assessments. Development banks require detailed ballast cost analyses before approving railway loans, understanding that material costs can determine project success or failure. Private investors conducting due diligence on railway acquisitions examine ballast condition and replacement schedules as key value drivers. Insurance companies assess ballast quality when setting premiums for railway property coverage, recognizing that inferior materials increase derailment risks and claim frequencies. These economic forces demonstrate why ballast selection involves complex financial calculations that extend far beyond the simple cost per ton of stone. The total cost of ownership includes material procurement, transportation, installation, maintenance, and opportunity costs from service disruptions. Sophisticated economic modeling considers all these factors over the entire asset lifecycle, typically spanning decades for railway infrastructure.